very happy to introduce Thomas, who's going to be talking to us about qryptr and air-gapped security. So take it away. Thanks.
Thank you very much, everybody. First of all, thanks to the organization for having me, and thanks to all the volunteers. I was at MCH in 2022, and it was amazing, really nice to see so many people get together, get organized to produce something great. I have a lot of cards, so if you want to have a reminder or something after the presentation, I'll just hand these out. So yeah, let's talk about my little project here. Let's see. If you have questions, just interrupt me. I'll be reading a little bit off paper as well, so just say question or A. I really don't mind being interrupted. So yeah, again, thanks to the organization for having me. It's a big fucking honor. It really is. So my little project. It's a little device. It's really a thing. It's hardware and software. It's a little box, and it's a secure, cryptographically secure text messenger. So yeah, during the talk, I'm going to be doing answering 3 questions. What does it do? How does it work? And why did you build this? So yeah, it's a first off, what does it do? What does it do, really? What does it do? So these are renders that you see here on the screen. It's an actual device, though, but just for presentation purposes, you can see here, what it is. So here it is, a little small to see, of course, for you all here. But yeah, this is what it does. So in simple terms, the device lets you put in some text, a message of 299 characters. It encrypts the text with a public key of someone else, and then it encodes the encrypted text as a QR code and will be displayed on the screen. So of course you need to have someone else's public key to encrypt the text. You can do that by first generating ID. The device will just generate a public-private key pair. You can share your ID. Bam, it will be shown on the screen as a QR code. And there's also a little camera in the back. So if you have 2 devices, the other person will just scan the public key of the other device. Bam, bam, bam. So it's like adding each other's IDs or just numbers or contacts or public keys, however you want to say it. So you add each other's contacts, then you write a message, some characters, and then it will be encrypted with the public key of the other person and then encoded as a QR code. So this all happens on the device itself. The device itself has no network connections whatsoever, so that means it's air-gapped from the rest of the world. However, you can make a photo of the QR code appearing on the screen with your smartphone, and then you just share the photo over WhatsApp or Signal or however you want to do it, send it over email. The other person will receive it on his phone and just scan it off the phone with the little camera in the back. And since he has his own private key, he can decrypt the message and read the message off the screen. So all encryption and decryption is done on the device itself, so no network connections whatsoever. So yeah, these are some photos of the actual device. So just communicating back and forth, both messages and public keys or IDs over QR codes. So this is a public key inside a QR code. And this has some more pixels if you can see it. So this is actually a message of 299 characters. So I hope you get a little bit of an idea of what it is and what does it actually do. So let's move a little bit to why did I build this, or why did you build this? So this all started in question.
How many identities can you have on a device?
The question is how many identities can you have on one device? So yeah, it's a lot, like a couple of hundred. Yeah. So why did I build this? This all started in 2015, a long time ago. I was playing around with encrypted email. what do I do now? Okay. I was playing around with encrypted email, which looks a little bit like this. It's just in your email, and I thought, oh, that's great. That's really great for let's say security of the message in transit. You could say it's end-to-end encrypted, but let's be clear, end-to-end encryption is up to and excluding the endpoint. So I was thinking, hey, if my laptop is hacked or if my phone is hacked, all this encryption is void, let's say. Someone can just make a screenshot after you decrypted it. Someone can just install a keylogger before you do the encryption. So yeah, what are you going to do? It was 2015, 2 years after, I think Edward Snowden released a lot of information that governments can and will hack anything. So yeah. All your fancy encryption is nice. So I came up with the idea, actually you need a separate little device to do the encryption and decryption. And so I started playing around with this idea, and the idea stayed pretty much the same from the end. You can use a QR code to, let's say, build the air gap or to gap the air gap. Yeah, I went through many iterations. I first had a small Linux-based computer with the e-paper, which also worked. But then you still have a whole operating system, quite some complexity. So in the end, I came up, I made a PCB that has a microcontroller on it, a display, a keyboard, cryptographic software, and a camera. So it all became a little bit more integrated into what it's now. And it took me a lot of time. And and throughout the years, all the stories about spyware and governments hacking every damn thing certainly kept me going, kept me motivated to work on this. So that's a little bit why I built this thing. I want to say one thing though. Technical solutions are nice, but I'd much rather have, let's say, political and legal solutions. It should be damn illegal also for the government to read your private messages. Unfortunately, that idea is a little bit out of fashion. Until we have better political and legal solutions, we're going to have to make do with technical solutions. And also, I want to tell you a little bit about why I built this, and that is because it was a lot of fun. I learned a lot. Of course, the application, the concept itself, the idea of the application kept me going throughout the years. But also working a little bit on it every day, coming up with a better way to do it, all the iterations. Yeah, I had a lot of fun learning about cryptography, electronic design, PCB design, and I just have a lot of fun. I had a lot of fun doing that. So also, if you're working on something, try to have fun. If you're all the time thinking about the end result of what you want to have, you can maybe be a little bit frustrated. So yeah, that would definitely be my advice. Try to have fun, and of course, that's a little easier if you're working on something that you really believe in. If you're just motivated by money, that can be a little bit harder, of course. So yeah, I certainly had a lot of fun. So let's go back a little bit to how does it actually work. So you have text, you encrypt it, you encode it as a QR code. You share that QR code over regular networked infrastructure, smartphones, laptops, I don't know what. And then the receiver decodes the QR code, decrypts it, and gets the text back. So a little bit the device itself, it has 5 components. So there's the camera, obviously, the keyboard, the display, some power management, the battery, of course, and then microcontroller, the RP2040, the Raspberry Pi Pico currently. And this is just a little bit how you put it together. This is all on GitHub. It's all hardware and software are open source, so you can just order the hardware yourself. So this is the PCB itself. Well, I don't know if you can see it very well, but there's the microcontroller, some power management stuff. You put a battery on there. There's a plastic spacer you can print out. There's a camera you put on into it. This is the display. And this is the front plate. So this actually has the actual keyboard itself. On the other hand, it's also a PCB. And then you slam it on top of there, and there you have it. So it's actually 2 PCBs sandwiched together with all the stuff that you need in between there. So let me, so that's a little bit how it works. So let's talk a little bit about the threat model. So most cases of spyware and hacks, they are done remotely. If you're a person of interest, for example, you're a system administrator, chances are much higher your router or your smartphone will be infected with spyware than someone coming to your house and installing a microphone or something. So this is the reason the device is built as such. So it's really built to counter, remote threats. Although I'll be touching upon, let's say, more localized threats as well. So this device really grants you a little bit of sovereignty. It's very simple. You can just see how it works. When you receive your device, you can just reset it. We'll clear everything and can just generate a key pair for you. So the current state, you can order one on qryptr.com, which means I'll make it for you and sell it to you at cost price, because there's not a profit thing. You can also build one yourself. The instructions are on GitHub. You can find the link on qryptr.com. And I will, of course, support you if you decide to make one yourself. Upcoming improvements. First of all, I'm very happy to say that NLnet has decided to reimburse me for some of the costs. I was accepted as a grantee for the NGI 0, the Next Generation Internet Commons Fund, which I heard last week. So NLnet, thank you very much. They're a non-profit supporting, let's say, the public nature of the internet projects they're about. So that's really nice. Thank you, NLnet. I'm really excited. So upcoming improvements, I still want to have support some more languages. So besides English, I also want to support symmetric encryption of the long-term key pair that is on the device. Currently, if someone steals your device, they can just figure out where what your key is, and if they have saved all your QR codes that you send back and forth, and the device of the other person, they can just decrypt everything. So I'm gonna basically implement a password protection for the thing here, which was one of the first things that NLnet mentioned. Hey, you need to have some symmetric encryption on the thing itself. So basically, a password protection. Without any way to, of course, I forgot my password, the option will not be there. There's also I want to use maybe another library. You're currently using the Arduino cryptographic library, which is not super well reviewed and supported, so I'll actually switch to Monocipher, doing all the cryptographic routines, let's say. Ideally, I also would like to make it even more lower power, use another camera, which uses a little less power, improve the UI. That's the improvements. So now we have time for questions. Yes?
What about the QR code attacks, where people try to circumvent your
Sorry, yes. So my question was about QR code, right? You're reading QR. So I can see people writing malicious QR codes, try to buffer overflow, do weird stuff. I don't know. Have those things been considered? Are you using a specific QR library? What are your thoughts?
Yes, of course. The airgapped is only, let's say, as secure as the QR code. You could even think about, hey, can I craft a malicious QR code that will crash the device? I did think about it. There are some improvements there to be made. Let's say having some tags around the QR code so you can see, hey, is this a valid QR code? I don't think it's a large attack factor.
It's the only one.
Yeah, exactly. So it's the only one, so you should still think about it very well.
So are you using a public library? Have you written something yourself, or?
All the cryptography is, of course, not done by me. But
the QR, for the QR code, are you using a library?
Yeah, there's a library that I use, yes. So
okay.
Maybe that's a good point. There could also, needs to be some scrutiny there. Well, I wish I had pen and paper. I'll record it, so I have your questions. Yeah, next one.
Yeah. Compliments on this work. You showed it before to me, and I already fell in love with it. So great for putting up because this is fun and useful. It's possible to extend the code, right? If I have an application such as, gosh, OTP codes are initiated, unencrypted, and then stored, and then you start using it. That's again the end-to-end encryption that you used in over HTTPS, but it could also end up in your device, and then it could be an OTP responder.
Sorry, I didn't really understand the question. So you're trying to integrate it?
Could your device be an OTP responder? Could I program your device to become an OTP responder? Do you have the ability to change the code? I bet it's open too, right?
Well, I think in general, either an OTP response or any other, let's say, integration with other systems would open. Yeah, you would have to have some network connection, perhaps. So in general, it's really just only text that you put in. So,
but I
think not. I
could extend the code.
I'm not really sure I understand.
Is your driver code open so that if I want to hack around in it, I could make extensions?
Oh yeah, everything.
Yeah,
everything. You can just fork it, do whatever you want. Yeah.
And another application I want to hand over to you that might be really interesting is Kerberos. You log on once a day, but the weak point is the password that you enter. If it's on your device, it's completely secure.
Sorry, I don't really understand the question.
I think you should both have a conversation afterwards in the bar or something. I've got one question. Oh, there's one here. My question while I walk is, you chose the Raspberry Pi chip. Why that over the ESP32 or something? Why the Raspberry Pi chip, not the ESP32 or similar?
Well, it's just a convenient microcontroller that I knew how to use. Plus, it has no network options at all. So ESP usually has a Wi-Fi or Bluetooth integrated. Yes.
Yeah, thanks for sharing the project. It was really interesting. Can you share us a bit more detail about the cryptographic protocol that you use? What kind of encryption, which public key schemes you use, etc.?
Yeah, we use quite standard ECC 25519 with a Cha-Cha cipher.
Cool. We might have one more question, if any, or... Oh, we have one more?
So one of the challenges in communicating with other devices mostly is key distribution. And now, of course, we can share the key, but if you share your key over the same channel that you also share your message QR codes, you're essentially already broken. How would you see any convenient way around it when the people don't meet in person?
I totally agree with your question. I think, one of the big questions in cryptography is, how do you make sure a certain key belongs to a certain person, right? That's maybe even more than half of the questions around cryptography. So indeed, the current model assumes that a meeting in person, because that is just a certain way to know, hey, I'm me and you are you, and this is my public key. You could transmit a photo of the QR code containing the public key over a channel you really trust, but of course, there the questions start. I think in general, how do you make sure that's actually the key of that other person? There's no innovation regarding that in this project. So basically it's make sure you meet afterwards, you have a secure channel.
So my question is to generate one private key, and you cannot make more than one private key, so because then to can decrypt one message with a person you have one private key with, and the other one don't have this private key, so you had more than one. Is it possible?
Yeah, it's indeed something I thought about. Well, let's say if you have the device, you generate your key pair, your private key. So indeed, it would be possible to have more than one key pair, you can say, hey, I have one ID that I share with this group of people or this person, and another private key that I use for others. Or you can just have a single one. For sure, it's possible. Would need some additional things. I think I wrote it down in the to-do somewhere, but yeah, it would definitely be possible. And yeah.
I also had a question regarding the cryptography. You said you use QRyptr as the encryption, so QRyptr 20. Did you use an AAD mode, so Poly 1305 or something? Because otherwise there would be replay attacks.
Absolutely. It uses authenticated encryption with additional data, so AAD, yes.
So key exchange, isn't that solved with Diffie-Hellman?
Well, yes. It's you generate the, let's say, the session key every time anew with the Diffie-Hellman exchange. Yeah.
Okay, brilliant. Well, that's been some interesting questions, and thank you very much, Thomas, for telling us about your project. And well, we'll have to have a look at the website if we haven't already, and possibly get one, have a play with it.
Thank you very much. Thank you very much. Send me your tips and requests, and maybe you get a card so you have a reminder. Thank you all very much. Really appreciate it.